Alrighty, children, it's time to jump into volume. Woo-hoo-hoo-hoo-hoo. Big fan of volume. I use volume all the time with like pouring concrete and things like that. So this is gonna be very exciting, children. And we have, if you noticed, paired prisms and cylinders together rather than prisms and pyramids this time. And there is a wonderful reason for that. So let's take a look at some of our prisms and our cylinder, of course, and think about why we paired these together. Well, all of our bases are in red here, okay? Now, if I were to just find the area of that base, and then I were to multiply it by the height, and the height doesn't always have to be up and down, it's just going back into the figure. So it's how often that base repeats itself in a way. If you stacked a bunch of bases going back, it would create that solid. So if I just find my area of the base, whether that's a circle or a rectangle, a triangle, a trapezoid, any polygon would do. And then you multiply it by the height, meaning how far back those are stacked or how high up they're stacked, then you will get the volume of that particular prism or cylinder. And when we write this formula, you'll often see it as volume equals big B times H. And this big B refers to the area of the base, whatever that base may be. But we often word it as big B, okay, representing our base rather than just a dimension of like a rectangle we refer to as a base, okay? Fantastic, wonderful, excellent. Let's do some stuff. So for the volume of this particular rectangular solid, many of you may know the formula length times width times height to get our volume. And although that is going to work, that is true, I'm going to follow that volume equals big B times H, just so it's more universal across all prisms, triangular, trapezoidal prisms, pentagonal prisms, you name it. If I find the area of that base and I multiply by the height, we're good. Now, what base do we want to use? Well, let's say I'm going to talk about this one as my base. So big B in this case would be a 3 by 5, right? I can use these dimensions for that one. So that would be 5 times 3 equals 15. So my big B is 15. Now, what's my height? Meaning, how far back are these stacked? Well, they're stacked back 7 centimeters. So 15 times 7, big B times H is going to give me my volume, which is 105 centimeters. And since there's 3 dimensions, it is cubed. Now, one thing to keep in mind with prisms, because some of you might be like, well, did I have to choose 3 by 5 to be my base? No, you could have chosen really any rectangular face to be your base. We could have done this one right here, which is the 3 by 7, but then my height would have changed to 5, okay? Or I could have chosen the 5 by 7 face to be my base, and then 3 would have been my height. Either way you slice it, you're going to end up with the same answer here, and that's just with rectangular prisms, okay? Wonderful. So we want to find the volume of this particular solid here. Well, what kind of solid is it? How do we know? Well, we're dealing with prisms, and we got to remember our generic formula is big B times H. So big B being the area of the base. So what is the base? Is it the one that's on the bottom here? That's a rectangle. I mean, that would make sense. It's sitting on the bottom. That's usually what I think of as a base. But no, that's not quite the case. Okay. And that's one of the main pitfalls that people have when they're figuring out these things. Our base is the shape that repeats itself twice. When we're talking about prisms, the base repeats itself twice. Okay, so these two triangles are going to be congruent triangles, and then the lateral area part is made up of rectangles. Okay, but these are our bases. All right, so if I find the area of that base being an area of a triangle, that's what my big B will be. Then I can just multiply that by my height, which is how far back these are stacked, 15. So H is equal to 15. Always good to jot down things you know. All right, let's see if we can figure this out. Well, I've got a triangle, a right triangle. I'm going to draw that off to the side, and it's a 30, 60, 90. How did I know that? Well, 30 and 90 leave me with 60 left over for the last angle. My hypotenuse is 12. Well, how do I address these 30, 60, 90 triangles? If you remember, we have reviewed this quite a bit. Our 30, 60, 90 triangle has 1, root 3, and 2. All right. A lot of times we'll throw an X with that if that helps you think about how you're multiplying and dividing. But in any event, how do I go from the 2x side to the 1x side? So how would I go from here to here? Well, I would divide by 2. So if I divide 12 by 2, I end up with 6. And then to get the other side, I multiply that by root 3, so I get 6 root 3. Those two, the 6 and the 6 root 3, those are my main key dimensions here with a triangle, right? My base and my height of a triangle have to be perpendicular to each other. And when I say base, I mean little b and h, okay? So this would be 1/2 times my base of 6 root 3 times my height of 6 in the context of the triangle, right? We're talking about the base and the height in the context of the triangle. So that gives me, 1/2 times 36 is going to be 18 root 3. So there is my area of the triangle. So if I want to calculate my volume, it's big B times my height, which is 15. So what's 18 times 15? Pop it in my TI-84, always strapped. 270. And then we pop that root 3 on at the end. This would be our exact answer, okay? This is our exact answer. And that would be feet cubed. If I wanted to get an approximate, I could just multiply it out. So 270 times the square root of 3 is going to give me 467.65. 467.65 feet cubed. So if I were plugging this into a Google form or whatever, where it asks you to round to the nearest 10th or 100th place, whatever it is, I would go ahead and plug that in my calculator and round. Awesome. So this next one, we want to find the volume of a cylinder if DC is equal to 6 and AD is equal to 10. And oftentimes you'll even see the word a right cylinder, meaning it's going straight up and down like that, like a soup can or a pop can or whatever. All right. Well, 6 and 10, these look familiar in a right triangle. Perhaps my diameter is 8. Not perhaps, it actually is. All right. Now, if my diameter is 8, what are my radii? My radius is 4 because that guy will cut in half. Whew. Man, we're moving fast already. Well, my volume formula, much like a prism, is just base times height, big B times height. But this time, my big B is the area of the circle. Well, what's the area of a circle formula? That's pi times my radius squared. Do I have my radius? I certainly do. I just found it by using my 3, 4, 5 triangle, doubled, and then taking that diameter and cutting it in half to 4. So I have pi times my radius of 4 squared. So this is going to be 16 pi. Excellent. Excellente. So if I have my big B, what do I need to do to find the volume? Well, it's big B, which is 16 pi, times my height of 6. That gives me 96 pi. That would be units cubed. This is my exact answer. What's my approximate? Well, if I plug it into my calculator by multiplying by pi, and I use the pi button, not 3.14, okay, we're very accurate here. I'm going to get 301.5928, blah, 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 blah. So 301.59 if we're doing 2 decimal places, units cubed. If we did 1 decimal place, it would be 0.6. Excellent, fantastic, wonderful. Moving on. As is tradition in honors geometry, we like to throw a couple curveballs your way. It says, what is the volume of a cube with a face diagonal of 8? Okay, so what does that all mean? Well, if I draw out a cube here real quick, so I got a square to start, and then I'll throw some guys back. Okay, there we go. There's our cube. Now, when they say a face diagonal of 8, they mean a diagonal on one of the outer faces, not through the prism, but on the face of it. So that's 8 right there. Now, if we remember, if it's a cube, it's a square face, right? They're all squares, 6 square faces. And if we throw a diagonal through a square, it actually cuts it into two 45, 45, 90 triangles. Ooh, how about a little review of 45, 45, 90 triangles? So I've got 1, 1, and root 2 in my 45, 45, 90 triangles. Or you can throw an x in them as well, right? 1x, 1x, and x root 2. So if 8 is my diagonal, how could I get this dimension right here of that 45, 45, 90 triangle of that square face? Well, I could divide 8 by root 2. So if I do 8 divided by root 2, I'm going to need to rationalize that by multiplying by root 2 over root 2, a clever form of 1. All right. So I end up with this, and then I can simplify that down to 4 root 2. So one of my edges is 4 root 2. And since it's a cube, that means all of my edges are 4 root 2. So I got my 3 dimensions, my length, width, and height. All right, so with a cube and a rectangular prism, you can use the volume equals big B times H, or if you are more comfortable with it, you could also do length times width times height. Okay, well, we can just continue on in the big B times H mode. And if I want to say, let's just say this face where I drew the diagonal through it, that's my base. That would be 4 root 2 times 4 root 2. And then my height would end up being that 4 root 2. But they're all 4 root 2, so it doesn't really matter. No, it's going to multiply out the same. Well, this ends up being 16 times 2, which is 32 times 4 root 2. And if I do 4 times 32, that's 128 square root 2. And that's units cubed. There's my exact. What's my approximate? Well, 128 times the square root of 2 would give me 181.019. So that's 181.02 units cubed for my approximate answer if I were asked to round it. Okay. Fantastic. That was fun. Brought back 45, 45, 90 triangles. As you can see, those special right triangles never go away. That's why they're so special. All right, we got another curveball coming our way. The numerical value of the volume and the surface area of a certain cube are the same. What is the measure of one of the edges of that cube? So the volume and the surface area are the same. So why don't we draw out a cube real quick here, because who doesn't love drawing these things multiple times? That's how you get better at drawing a 3-dimensional thing on a 2-dimensional thing. All right, there we go. I don't know why I dashed these. That's strange. There we go. All righty. Now, all of my sides in a cube are the same length, right? And oftentimes you'll see them as just like an S for side. Okay. So, in other words, the volume of this would be if my base was this front face here, right? That'd be side by side, side times side, and then I'd multiply it by the height, which would be another side. So it'd be side times side times side, or in other words, side cubed, right? Now for my surface area, how about I use a blue marker here? Bears, blue and orange. All right. Surface area, I would need to add up all of my faces, right? Um, so let's see here. Again, I could have my I'd have a side by side, so side times side, and I'd have 2 of those, right? I'd have side times side over here, so I'd have 2 of those. Well, hold up, aren't all my sides or my faces the same? So really, if I found one of them, side times side, I would just go ahead and multiply that by how many faces? 6. Okay. So I have side squared times 6. Now you might already be seeing what's going to be happening here, but if I want them to be the same, I need to set those two equal to each other. So I would have side cubed equals side squared times 6. Okay, so how do I find out what the side length is going to be? Some of you might already see the answer. You might already be looking ahead and be like, oh, I think I know what it is. But let's go through the algebraic way of solving shall we? Uh, how about, since I'm dealing with a cubed variable, a squared variable, what I can do here, and I'm just going to switch to black ink now, is I can bring everything over to one side. So that's side squared, and then that equals 0. That's common for any kind of like a quadratic or a cubic. I'll set it equal to 0 to solve. Now, these two have a side squared in common, and I'll be left with side minus 6 equals 0. So I have s squared and I have s minus 6 as my two factors. Well, I can set s squared equal to 0, and I would get s equals 0 when I square root both sides. And then I would have s minus 6 is equal to 0. So I get s is equal to 6, which is the answer in this particular case, because I can't have a side length of 0. That would be a solution I'd have to eliminate. Now, some of you might be thinking, oh, why didn't I just divide by side squared over here? And you absolutely could, and you would have gotten s equals 6, but you would have missed out on these solutions. There's actually two of them because this is squared. And although not important for our class because we eliminated the 0 anyways, in the future, in Algebra 2 honors, pre-calc honors, calculus, you don't want to eliminate a solution like that. It can cause issues in other units. So I did want to go through the proper algebraic steps to solving a problem like this. In our case, 6 is our answer. All right, last problem here, guys. I know this video's got a little lengthy. I appreciate you hanging in there. So I got to find the volume of this solid here. What kind of solid is it? Well, I see some rectangles and triangles, but as we know from previous problems, when we see the same thing twice, there's our base. It's a triangular prism. And of course, our generic formula of volume equals big B times H. Woo! We all good there. I like it. Excellent. Wonderful. So I got to find the volume the area of my base. So the area of the triangle, that is my big B, right? Okay, well, let's figure it out. It looks like I have an equilateral triangle for my bases, right? I've got, it's 5 by 5 by 5 if I bring this 5 over. Okay, awesome. Well, there's a couple ways of finding the area of an equilateral triangle. One, we could split it into 30, 60, 90 triangles and get 2.5 here, get a 60 here, 30 here, and go about it that way. And that's all up to you. If you do remember, an area of an equilateral triangle, there's a special formula, side squared root 3 over 4. And I'm going to use that because I remembered it, and that's kind of helpful. So for that one, it's just 5 squared root 3 over 4. And again, if you didn't know that, you can use 30, 60, 90 triangles to figure it out, and that will work the same. You'll get 25 root 3 over 4. That's my big B. So what am I going to do with that? Well, I'm going to plug it into my volume formula, 25 root 3 over 4, multiply that by my height of 9. And if I do that, what do I end up getting? Well, what's 25 times 9 here, children? Woo, 225 root 3 over 4. And that's inches cubed for my volume. That's a goofy looking 3 there, but whatever. And if I wanted to find my approximate volume, I would just plug that in the calculator. I'd get 97.42785. So 4.3 if we're going with 2 decimal places. Lovely, wonderful, fantastic. America, freedom, rock and roll. Thank you for sticking around here, children. Have a fantastic day and enjoy doing the wonderful homework.